So Dr. John's map was able to specially associate flora cases with a single contaminated water pump. This led to three positive changes. The water pump was disabled, preventing further deaths. So flora was identified as a waterborne disease, and efforts began to improve the water and wastewater system in London. But initially, nobody really believed Dr. Stowe that it's because of the water. So, but later on, anyhow, shown there is the map created by Snow in 54, as well as the same data represented with the heat map symbol. So the yellow part of the map represents the highest density of the flora death cases, which coincided with the Broad Street water pump. So what they did at the end, they removed the handle from the, when they figured it out, they believed, so authority removed the handle from the water pump and the flora epidemic subsided. So this picture is showing the current location of the Broad Street pump today, So the GIS application is huge in water quality mapping. We will discuss it so recent work in the field of remote sensing NG, what the traditional way of mapping and reporting of water quality data, if it's groundwater or if it's surface water, is just people are just collecting those data and presenting them in a tabular form, just like you will be doing in some of the case studies. So here is a couple of case studies about the special analysis of groundwater quality in the Peshawar district. This is the a map of the Peshawar. So one of the graduate students took more than 100 samples of groundwater quality data. Samples from the tube wells and analyzes physicochemical properties of that data created. So this is, let's say, this is a typical scenario, where people report their data, in tabular form. If you look at the mean, median, mode, so you cannot really tell, where the pH is high or low, where the problem is, or if the nitrate, chloride, and all those, and this is the cross correlation map of different physicochemical properties. So here is the different special distribution maps of different parameters. Let's say the EC, the pH. So from this map, those special distribution map, you can tell where the problem is. Rather than if you go back and use a simple tabular data. So here is the special distribution of turbidity, magnesium hardness, chloride, and nitrate concentration. So mostly, if you look at the nitrate concentration, it mostly concentrated in the southern part of Peshawar, where major agricultural activities is going on. So it means that people are over using the nitrogen fertilizers, and that's leached down to the down profiles. Then we use the same data. The previous studies was conducted in 2014, and gave it to another student. So to look at the temporal change in the water quality data. So the impact of land cover changes on water quality and human health in the district Peshawar. So what he did, he used the current data and the previous data. Data from the 2014 and 2019. He compared the physicochemical properties of those two sets of data, and used the Landsat imagery, to figure it out, the recent land cover map, and try to figure it out. So this is the study area map. So he collected like more than 100 maps, 100 sampling points from the tube wells for both. He had the 2012 data and 2018. He sampled on his own, all those tube wells. So here is the, let's say, if you look at the pH, in 2012, there was not much of an issue, in the 2012 groundwater pH data, but if you look at the 2019, the pH is deteriorated a little bit, it's showing more than 8. So the same thing with the electrical conductivity, there is not major issues, but some of it in the central Peshawar area, that you can see some of the speckle points, And the same with the nitrate, if you look at it, the nitrate map, there is no issue in the 2012 data, map, but if you look at the 2019, you can see a huge, a lot, high concentration nitrate in the groundwater in the southern part of. So this is most related to the agriculture, major agricultural activities are going on in this area, Then similarly, the chloride concentration hardness and this calcium hardness, and this is the difference between the two years, 2012 and 2019 land use land cover data, So if you look at it, the major changes that is going on, is in built-up area that's increased a lot, almost from 17% to 22%, and the agriculture, it's quite decreased, So it means that most of the agriculture area have been converted to residential areas, So because of the population pressure, that could be the reason. So the effect of land use land cover change on water quality. If you look at the nitrate, in the agricultural areas, so that's increased, quite a bit from 18 ppm, let's say, to 84 ppm, In the same case with the rangeland, and the other land use land cover areas, So then we have conducted similar kind of studies in Rawalpindi district, try to look at the physical-chemical properties of in the Rawalpindi area, the Rawal town, one of the major town, in Rawalpindi, So we collected this data, from the WASA department, the tubal data, and looking at the physical-chemical properties and gastroenteritis, So this is a map of the fecal coliform count, for the study area, and you can see that where the high concentration of fecal coliform bacteria is, The same thing with the socioeconomic data we had, for let's say the literacy rate, and try to relate that with the different physical-chemical properties, So these are some of the maps, the pH, chloride, turbidity, alkalinity, So from this perspective, you can see, to where the issues, where the problem is, rather than just using a tabular form of data, So then those 7 physical-chemical properties parameter was used to try to construct the water quality index, and you can see that the problem areas in this town, Rawal town, so this area might have a drinking water quality is unfit for consumption, So similarly, the gastroenteritis, which was correlated with the fecal coliform literacy ratio and shortage of toilets in the Rawal town, and you can see the Pearson correlation coefficient, in some of the areas they are highly correlated, significantly correlated. Then the last study that I'm going to discuss, the special distribution and mobility assessment of the carcinogenic heavy metals in the soil profile using the geostat or special data, You can see, wastewater in Pakistan is discharged to the nearby river, canal, drains or open land without any prior pre-treatments, which ultimately causes pollution of surface and groundwater. So, for example, the picture showing in A, is the municipal wastewater destroyed in the drains without any treatment. Then, in some area, they also grow the vegetables, using this wastewater, and obviously it will uptake a lot of the heavy metals, that we are consuming, So this was like six. This is pretty close to Lahore. This is called the Shekhupur Industrial Zone. So what we did, we took like 60 samples, selected 60 sites, through this study area. It had a lot of different types of industries like batteries, colors and dyes, chemical industry, leather industry, tanneries, textiles. So they are using very high amount of heavy metals, in those industries. So we took like 3 depths, samples from 3 depths, So we want to see that how the heavy metals are moving in the soil profile, So these are some of the results, that the most of the heavy metals are within the limit, except the cadmium, in all those 3 depths, Similar, the correlation coefficients matrix for physical chemical properties. So these are the maps for different horizons, the surface for the heavy metals, the surface and subsurface. Same thing for the cadmium and the lead, Thank you.
Thank you, Dr.